These are the notes for section 4.2, proving congruence SSS and SAS. The objectives are to use the SSS postulate and the SAS postulate to test for triangle congruence. The first thing we need to recall are what was covered in the 4.1 notes. It says when two triangles are congruent, all 6 pairs of corresponding parts, their pairs of angles and pairs of sides, are congruent. So that was what we defined congruency to be. So in this section, we're going to learn a couple of shortcuts where you don't need to show that all 6 pairs of corresponding parts need to be congruent. The first one is the SSS postulate. This says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if the triangles are congruent, that means that the angles that correspond with them are also congruent. So if I say segment AB is congruent to segment DE, so there's AB and DE, BC is congruent to EF. So I'll put 2 tick marks for BC and EF. And finally, AC and DF. AC has 3 and DF has 3. Then that's enough to show that the 2 triangles are congruent. If all 3 sides are congruent, the triangles are congruent by this SSS congruency postulate. The next important concept we're going to talk about is what's called an included angle. So an included angle, this just kind of means between. So in triangle ABC, angle B is the included angle between sides segment AB and segment BC. So here's AB, here's BC, the included angles between them, angle B. So they ask us, what is the included angle between sides AC and BC? Well, AC I'll do in blue, BC I'll do in blue. That means angle C needs to be the included angle between those 2 sides. So the included angle is important because we need it for the SAS postulate. This says if 2 sides and the included angle, so there's that word included, of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So what we're going to show here is NM and PQ are congruent. So segment NM is congruent to segment PQ. The angle that I'm going to have is going to be angle N and angle Q. Angle N is congruent to angle Q. And to make that the included angle, I need the other side of the angle. Segment NL is congruent to segment QR. So there's my SAS. So triangle MNL is congruent to triangle PQR by side, angle, side. So for the next page, we need to figure out which triangles are congruent. So if we read the directions, it says decide whether enough information is given to prove that the triangles are congruent. If there is enough information, state the congruence postulate. So if there is enough information, state the congruence postulate. We're going to do the odds together. I want you to try to do the evens. So our 2 options are SSS or SAS. So let's take a look at number 1. Number one, we have one congruent side, two congruent sides, and what I see a lot of students do for a common side is they'll put 3 marks down. So I like that thing that they do. So this is congruent by SSS. So it says whether enough information is proven. So yes, there is enough information. And we would use the SSS postulate. I'm going to take this one step further and write a congruence statement, which it doesn't ask us for. The best way to write a congruence statement is to kind of think the direction, just like we did in 4.1. There's 1 tick mark there, 2 tick marks, 3 tick marks. So I'd write triangle X, Y, Z. And I'll do the same thing with the other triangle. I'll start going 1 to 2 to 3. So it's going to be ZWX. So that's congruent to triangle ZWX. Let's take a look at number 3. One additional piece, there's a few additional pieces of information we could put on the diagram. First off, we know that this also must be a right angle because that's a linear pair. So the points T, R, and G are all on the same line. We also know that AR is a shared side, so I'm going to put 2 tick marks there. So I have a side, one side. The included angle is there also. The right angles are the included angles. So these are congruent by the SAS postulate. Again, we'll use that same trick where we go 1 to 2. That's going to be triangle GRA. That's going to be congruent to 1 to 2 again, TRA. So let's do one more example together, number 5. In this example, there's another piece of information we don't have. AE is congruent to AE. So we have one side, 2 sides, but we do not have the included angle. We're given a different angle. This angle is not included. So since it's not included, that means there's not enough information. We also don't have the third side to make it an SSS. So this one here is not enough information. So remember, the angle needs to be included. The angle is not included. We also don't have a third side congruent. So what I want you to do is try numbers 2, 4, and 6. Make sure to add the information that's extra if there's anything missing. So for the next few examples, it says use the given information to mark the figures. So we need to mark the figures and decide if the triangles are congruent or not. If so, write the postulate and the congruence statement. So let's fill in the information. Remember, this upside down T means perpendicular. Perpendicular meant 90 degrees. So we're told that BD is perpendicular to AC, so that means I have 2 90-degree angles. And I'm also given that segment AD is congruent to segment DC. The information that I'm not given by the words, but by the picture, is that BD is congruent to BD. That's just the reflexive property. So these will be congruent by SAS. So we wrote the postulate, and now we will write the congruence statement. So again, I'm going to go 1 to 2, and then the other side. So that's triangle ADB is congruent 1 to 2 to the no side, triangle CDB. So what I'd like you to try is to try number 8. Remember, we have vertical angles. That's what you're going to need to label. We've talked a lot about vertical angles, so hopefully you'll be able to detect those on that picture. Let's do number 9. It says given segment XZ bisects segment or angle WXY. So WXY, angle WXY is right here. When it bisects, that means it cuts it into 2 equal angles. We're also given that segment WX is congruent to segment XY. And again, by using the picture, we have the reflexive property. XZ is congruent to XZ. So this is side angle side. And if I want to fill in the letters, again, 1 to 2, that's triangle WXZ is congruent to, I hit YXZ, triangle YXZ. So you should try number 10. And in order to do this, you have to remember that alternate interior angles are congruent. For number 11, we're told C is the midpoint of segment BD. So that means it cuts it into 2 equal segments. That's what midpoint means. We're also told that segment BE is congruent to segment ED. I'm going to use 2 tick marks because I already have one on BC and CD. Lastly, we have the reflexive property where CE is congruent to CE. So we have all 3 sides congruent. So that would be the SSS postulate. When I fill in the letters, I go 1, 2, 3. I touch C, B, and E. Triangle CBE is congruent. So I go 1, 2, 3. Triangle CDE. So let's do number 12 together. 12 is a little bit different because it says write a proof for each of the following. It tells us to mark the figures before you start. So we're given segment LM is congruent to segment PN, and we're told that segment LM is parallel to segment PN. So remember, this symbol here means parallel. All right, so as it stands, we have 2 congruent sides because we have the reflexive property. That's not enough. We need more information. Well, because these lines are parallel, I should remember back from Unit 3 that when I have parallel lines in this transversal, the alternate interior angles are going to be congruent. So those 2 angles there are going to be congruent. I'm going to clean this up so we can see the letters better. If you missed what I did there with extending the lines, make sure you rewind the video. We have those 2 angles, and now we have side angle side. So at the end, I know my answer is going to be side angle side. And I could even do this backwards. I would go 1 to 2. That would be triangle MLN is congruent to triangle PNL. So that should be the last step because I want to have this prove thing. I didn't use the same letters. I guess I should have used the same letters. But they are the same triangles. The position's the same. So let me just write in what we have here. Triangle LMN is congruent to triangle NPL. That's always what we want in our last step of the proof, and we never want to write the reason proven or prove. We want to write SSS or SAS. Now we can actually write the proof. We kind of did all the steps. So now we need to explain our reasoning. Remember, our first reason always has to be given. So I'm going to use some of my given information. Segment LM is congruent to segment PN. And on the right, I can think this is a side. So for my last reason why, I can write it's a side. We're also given that segment LM is parallel to segment PN, and that's also given. That's not telling me any sides or angles are congruent, though. It's just telling me the lines are parallel. The next part will give me the angle, though. We said angle MLN is congruent to angle PNL. This is because alternate interior angles are congruent on parallel lines. And that gives me an angle. So I have a side, I have an angle, and the last thing that I have is segment LN is congruent to segment LN, and this is the reflexive property. So we already explained all of those things, and hopefully you were able to follow all of that. This is just a formal way of writing it. So whenever I take a look at it, I have side, angle, side. And there's my reason, side, angle, side. Let's do one more of these proofs together. And you should try number 13 on your own. You should try 13 on your own. Number 14, the information that you should always write in is given for your first reason. And you should write triangle AED is congruent to triangle BEC. That's the information that will be on all of your proofs. So whatever's given, and your last step should be whatever it was you were trying to prove. Actually, as I review my notes, I see that I used an extra line, and it went down here. All right, so the directions told us to label our figure. So it says E is the midpoint of AB, so that means it cuts those two into two equal segments. It also says it's the midpoint of DC, so we have two more congruent segments, and we should see that we have vertical angles. So these triangles will be congruent by SAS. So let's fill in the information. E is the midpoint of segment AB and segment DC. So that's my given information. The next step is to say segment AE is congruent to segment BE. That's just the definition of midpoint. A lot of times in our proofs we can write definition of something if we're stuck for a reason. We also know that segment ED is congruent to segment EC. Again, we were given we had a midpoint, so this is just the definition of midpoint. So whenever we're figuring this out, we should have a side, and we just need the included angle or the third side. Well, in our picture, we have the included angle. We have angle AED is congruent to angle BEC. And our reason is vertical angles are congruent. And that's my angle. So since I have two sides and the included angle, remember it's very important that you have the included angle. That's enough to show my last step. Triangle AED is congruent to triangle BEC. I hope this was helpful. I wouldn't be surprised if you guys struggle with the proofs. Again, try number 13 to the best of your ability. When you mark the sides and the angles, it should be pretty easy. I think it's the easiest proof on there. Come to class prepared with any questions. Have a great day.